Good evening, friends. Now we have taken a series of lectures for UV visible spectroscopy chapter. Now here there are a number of applications associated with the UV visible spectrophotometer. Now colorimeter has also different applications for different chemicals and different determinations, different concentrations. Now here colorimeter is used to measure the colored intensity of different concentrations concentrated solutions. Now the concentration is nothing but the amount of substance present in the solution. Now in the colorimeter, the intensity of colored solution decides the concentration of this analyte. If the analyte is not colored, then it should be bring into colored form. Then it will be determined for the colored compound for the concentration. Now if you take example, now here an application is given, that is a spectrophotometric titration. So with the help of spectrophotometric titration, we can determine the concentration of the amount of a chemical. For example, determination of copper 2 with EDTA. Now copper can be estimated spectrophotometrically with the help of ethylene diamine tetraacetic acid, that is EDTA complex, spectrophotometrically. Now here spectrophotometric titrations. What is the definition of spectrophotometric titration? Before that, the titration in which absorbance of the solution is used to determine the end point is called as a spectrophotometric titration. Now in the titration, if the end point is comes with the aid of absorbance of the solution, then it will be spectrophotometric titration. Now here we are going to learn about the example, that is copper 2 with EDTA. Before, we must know that copper can be determined colorimetrically also. But in colorimetrically, when we determine the copper, there is no use of EDTA. We can't use EDTA. In the procedure of colorimetric determination with copper, we use a different standard solutions of copper. For example, we prepare a copper 2 ml, 4 ml, 5, 6 ml, 8 ml and 10 ml. That is increasing concentration of copper. Again, we prepare a blank solution and we prepare a test solution or unknown concentration of copper is given. Now there are these near about 7 type of different solutions are given. Now when we prepare a standard solution with increasing volume of up to 2 ml to 10 ml, at that time we add similar quantity of 2.5 ml ammonia, which is nothing but the coloring agent for the copper. Now in that procedure, we get, when we use the blank solution, at that time we determine the zero absorbance in colorimetry. Now after that standardization with the help of blank solution, we further proceed for the determination of lower to higher concentration of copper solution. Now when we there is obviously we get the absorbance from higher to lower values, and we again measure the absorbance for the unknown solution. At that time we prepare a plot, that is absorbance versus ml added. When we prepare a plot, that graph is nothing but the calibration graph or calibration curve. A calibration curve of copper is plotted with absorbance versus ml of titrant added. Now here the volume of unknown volume that can be determined by calibration curve method, and with the help of calibration, with the help of that unknown volume that can be multiplied by the molarity of copper, we get the amount of copper present in that colorimetric determination of copper. We get the unknown volume of copper in test solution in colorimetric method. Now, similarly, here we determine the EDTA, we determine the copper 2 plus solution with the help of EDTA. Now, for that purpose, selection of wavelength is very important. So we select a wavelength 745 nanometer. So this wavelength is very important because this copper 2 solution with EDTA, with EDTA added into EDTA, has a molar extinction coefficient to this lambda max value. So this wavelength is selected for that purpose. Greater molar extinction coefficient is there. So this at this lambda value, the solution has a molar extinction coefficient that is higher or greater. The pH of the solution is 2.4. Now, what are the reagents are added for that purpose? The molecular weight of copper 2 pentahydrate is 249.08. Now, with the help of that molecular weight, we prepare a 0.04 molar copper sulfate. 1.25 gram of copper is added into 5 ml of nitric acid, concentrated nitric acid, and then it is diluted further with the help of distilled water up to 1 liter in volumetric flask. So 1.25 gram of copper is measured with the help of measuring instrument, that is a weight balance. After that, it is dried and ignited at up to at 100 degrees centigrade. The cleaning of copper is done through this procedure. Then there is addition of 5 ml concentrated nitric acid so that copper will get dissolved easily, and then the total volume is make up to 1 liter. Now the next point is titrate this solution with EDTA solution by using fast sulfon black indicator, and thus obtain a molarity of EDTA. So the further solution, that is a prepared solution, is the next. It is titrated further EDTA to get the molarity of EDTA. So EDTA 0.1 molar and buffer solution has a pH 2.2 pH is preferred, 2.2 pH. Now here procedure is given. For that spectrophotometric determination of copper 2 by EDTA, take 10 ml of copper ion solution in spectrophotometric cell. So cell or cuvette is used. Add 20 ml acetate buffer solution. So if you take a large container, okay, it's a large beaker, add 10 ml copper ion, prepared copper ion solution. Add 20 ml acetate buffer solution. So 10 plus 20, that is 30. Total volume becomes 30. And add 120 ml distilled water. Set the wavelength 745 nanometer. So for this, we can say the instrument have the lambda max value, or it should be the lambda max value to be selected is 745 nanometer. Adjust the slit width so that reading on the absorbance scale is 0. Now with the help of slit, we just measure, we can say we just convey the reading up to 0. Stir the solution and titrate with the standard EDTA. Now here, to get the molarity, we are going to add, we stir the solution and titrate with standard EDTA. The EDTA is nothing but it is a complexing agent. That is a complexing agent. It is ethylene diamine tetraacetic acid. Read the absorbance every 0.5 ml until the value is 0.2. Now we get the absorbance 0.2 and subsequently every 0.2 ml. Now here, when we add continuously add 0.5 ml, at that time take the reading also. This is important. Continue the titration until about 1 ml after the end point. So continue the titration until about 1 ml after the end point, 0.2 ml, and that should be added continuously. And that addition is continuously going on up to 1 ml after the end point. absorbance fairly remains constant. So one equivalence point is we get, and at that equivalence point, absorbance value is further remains constant. We get, further add the EDTA. Plot the graph of absorbance and ml of titrant added. Inspection of two lines is the end point. Now here intersection, we take the intersection of two lines is the end point. Calculate the copper concentration and compare with the true values. Now here absorbance versus titrant added. This is the graph is plotted. This is nothing but the increase in absorbance with the addition of ml of titrant added. Now at this point, this is the point here. After this point, the absorbance remains constant. Now we take the intersect of this line and we take the intersect of this line, and this point is nothing but the equivalence point of the titration. So this equivalence point, with the help of this equivalence point, we determine the concentration of copper 2 present in that particular test solution. So with this content, I conclude this lecture. Thank you very much for your patience listening.